Hi. In the last video we will discuss the basics of KNN and where it is good to apply the KNN and where it is not good to apply the KNN. What are the some problems in the KNN? That means the first problem that we have, time complexity is a problem. Second problem is K value, finding K value. This problem we saw in last video. This we will avoid this problem by using the k-fold cross validation technique. This is the technique that we are using to avoid this problem. And in this video we will basically deal with how to avoid the time complexity problem. Before going to the time complexity problem, we will see a good thing that is okay. Let's say query point. This is the query point. Okay, this is the xq and the we'll use yellow color for this one. Okay, for k equal to 5, it will find these two points from the positive class and these 3 points from the negative class, but actually then it's classified as a negative class. Okay, by this way we can we know in KNN. But here we can observe that these 2 points, positive points, are very close to the query point. Actually, these 3 points are very far from the query point. It is not good way when this was like this. Instead of that, if we give some weights according to the distance, for example, these two are close because they have more weights are more. These 3 points are far from the query point. We will give less weights to these 3 points. Okay, weight is equal to 1 by distance. Okay, by this way we will, if we give like this, these 2 points will get more weight compared to these 3 points, and so this query point is classified as a positive point. This query point is classified this is the one of the technique in the KNN to avoid some problems facing basically in the KNN. Now we'll see with an example. Here it was the same thing. Here this is the query point. We will classify these 3 points are one class. These are one class. These are all one class. But here this, when k equal to 5, it gets the two classes, 2 points from this class, 3 points from this class. Okay, and according to the weights we will give. For example, the distance of these 2 points t1 like this, the distance are very less, and these 3 points having the distance like this. Okay, and according to the distance we will give some weights. The shorter the distance, higher the weight. Shorter the distance, higher the weight we will give. Because of that, these two are shorter distance, we will get more weight. 10 plus 5, we will get 15 as a weight for both. And for these 3 points, positive class were far from the query point. Okay, test point. Because of that, they got more weight, very less weight. The total weight here that was get due to the positive class is 1.75, and because of negative class it is a 15 weight it will got. Because of 15 is more, and it is classified as a negative class. The query point is classified as a negative point. Now this is the like that. Now we will see KD tree. KD tree is the technique that KD tree is one of the technique to avoid the time complexity problem in the KNN. And generally during the when dimensionality is very less, then we have order of n during the test cases in the KNN. But we will reduce the order of n to order of log n by using the KD tree technique, by using KD tree methodology. Okay. In the KD tree, the basically using the technique is binary search tree technique that we are using. The binary search technique, we know actually if we given a list of points, okay, we'll sort them those values, and according to that, for finding we will split that one into first one. If the value, if what we want to find, for example, if we want to find the value of 2, okay, want to find the value of 2, here we will split here 8 by 2 4, below 4 belongs to 1, and greater than 4 it, that means at 4 we have 8. The value what we have to find is 2, it is less than the 8, that means you will search here, and here we have 4 elements, 4 by 2 we will get 2, we split here these 2 points, at 2 we have value of 2, that means we will find here in the 3 steps we will find the value, but before that we need to sort the values, that is the main thing. For the sorting also it will take time. If we have many searching, that means we need to find 2, 17, 18, like that we need to find many values, it is the good technique to find, instead of going to the every element. It is the one of the good technique in the searching mechanism. Okay, now this is the graph that we will, what I am say, that was the same thing. Here we represented by this tree like algorithm, it is like a tree like algorithm. These mechanism also used in same in the this also. I will have one example. Here we will see the KD tree. Okay, yeah, KD tree. The KD tree, here are the points. Okay, we don't know which, we need to find the nearest neighbors. What is the problem in the KNN? The KNN we have a problem of time complexity or order of n test case also, because we have to find the test class also, we need to find the distance between the all the points from the query point. To avoid this problem, we are using this mechanism. In this we will split the, for each point we will create a region, its own region. For this we will use the binary search mechanism. We will create, how is the algorithm is, we will split this whole region into small region by using the axis parallel lines, because here we have 5 whole 10 points are there. We'll split the first in this axis, then first we will split based on this axis, we will split like this. Okay, I will use another color, that will be good. Green is better, right? Sorry. Yeah, we will split like this. That means the value is less than this value, and greater than this value, and next we will split, now we split this axis. Now we will going to split based on another axis. This is the another axis. By here we will split, Here we have 5 points. If we split, we can split like this only, because by taking them in we will go through this way. Similarly for here also, for here we will split like this. Okay, by taking the mean, we will, if we get like this, we will go through this way. This is the same thing I am drawing here also, x2. Now we are done on this axis, x2 axis. Now we will go to the x1 axis. Here we will split like this, and the same thing we are do here also, and similarly we will do same thing here also, and here also in this region also 2 points we will split. 2 here 2 points are split. We will see now in the each region it has only 1 point that we can observe here. Okay, and these points also coming to one region. I'm not good at drawing. It will be going to this region, maybe like this. If we get this one, it will go like this. This is the region. In this region, this point belongs to this region. Okay, when the quarry point came, what will be happen, that we will see now. In the quarry point, this is the same thing. Here we will consider, median. Median is the, we will consider, by using the median we will split. Okay, and coming to the quarry point, this is the like behind research tree. In the last we will see. Yeah, I will explain that one also. It is good to explain that one also, I think. Come on. Yeah, let us see. Here we split based on the x-axis first, because here they consider x and y, two axes they are considered. We split based on the x-axis, and some points are classified this region, and some points are classified in this region, that we can observe above. Okay, that we can see here clearly, we can see here. Okay, here when we split the base by using this value, x1 is the value of median that we are get. When we draw this one, these are the points that was belongs to this region. These are the points that belongs to this region. We can observe 6 and 8 9 10 are there. These are the things here also. This is the point in this region. We split based on the x-axis. Now we will going to use y-axis. By using y-axis we will, I think this is the next line that we are get here, and this is the next line, because here these 2 points and whole there is 5 points. Okay, now by using that, when the quarry point is came, when a quarry point, here we can observe this. This is the quarry point. When the quarry point xu came, it will firstly check in what region it is. It is in the C region. It is in the region of C. For example, I will explain with the I lost one thing. Yeah, I think this is the not. Yeah, here when a quarry point xqs came, here here xqs came, it will firstly find the distance of the point in which region. It will firstly find the distance from this, because it is in this region of E region. It will find the distance. With the distance it will make a circle like this, hypersphere. If it is a 2-dimensional, we will call it sphere. If it is more dimensional, we will call it hypersphere. Now we will check it was touching this axis, that means this region, and also it's touching this region. Okay, because of this touching these two regions, it will also find the distance of these 2 points also. Okay, when finding these 2 points actually very far from this point, and it is classified this one into which class it belongs to E. But when we consider if it is close to this point, then it will be classified for this point. For example, if it is close to here, if it is close to here, that means your query point is here. Excuse, if the query point is here, then it is definitely classified into the, it is very close to the C, and it is classified which class it belongs to, that class the XQ also classify. I think you got my point. And this is the thing that we can observe. I will show an example, then it's very good. And yeah, we can see here. Okay, sorry, I'm not going to connect the internet. Okay, no problem. Yeah, this is the KD tree is the technique that we are using to avoid the problem. What I am telling this one, initially it belongs to C. It touches an axis that for x5, it will go to there, and also it will check these regions, and also it will go to the, it will touch on y1 region. Because of that, it will go to that region, it will check these all the things, finally classify which class it belongs to. By this way, what if here also we have a problem, that is the more number of regions the query point touches, that means it has to move more number of regions, that means at that time also it will take more complex. That means that is the one problem that also here. Here by this way we will tell the best case is order of log n. Order of log n is the time complexity. In the worst case, another technique to avoid the time complexity is locality sensitive hashing mechanism. That is the one thing that we are using to avoid the time complexity in the KNN. Here we use the hashing mechanism. You know the hashing mechanism, how we can use, we will use an hash function. According to the hash function, we will have a hash table like a dictionary. We will send the, by sending the value to the hash function, we will get the key. According to the, we will store the values in this bucket. Okay, like that. That is the thing that we are using. Okay, that is the basic thing. By this way we know why, because the dictionary is the, you know, the Python dictionary is the time complexity of order of n. To go to the any key, we will get within order of 1 is the time complexity in the dictionaries that we know. Very fast dictionaries create like. Let's come to the point in the KNN. Generally we have the points like this. We have the values. These are the classes belongs to one class. Okay, and these are the, sorry, these are the points, and these are the, there are some region. These all the points with hash table we will send to the, we will get a key. According to the key we will send this point. For this all the points we have same key. And similarly, if we will consider one more thing, for this all the points we will have same hash function. By using this way, okay, for example this is the query point. If this is a query point, it is only find the distance of these all the points. It won't go to the another region like this. if we have the region like this, okay, I will use this is the another region. If you give a query point, okay, if you give a query point, this is the query point, it's a query point given, it will only look in this region only, it won't go for this region, okay. That means you have less number of points we are considering. By using this we will get a early results. That is the basic thing that we are using. But how can we get this region, this the region? For this we have three different techniques. We have different techniques for that also, we will see now. One technique by using the cosine similarity thing. That means, okay, the cosine similarity have cos theta, we will get cos theta value. Based on the cos theta value we create a hash function. Very close points are sent to this hash function, will have when we send to the hash function, and we will get the key. That means these two x1 x2, when we send to the hash function h, it will get same key. That means these 2 points we will send to the same bucket, okay. Similarly x3 will go to the another bucket. This is the one thing we are making, these two are in same region, this is another region, okay. This is the one thing. And another technique by using the randomized algorithm. In the randomized algorithm we will create a planes, that means we will create a random planes like this, okay. These are the points. Based on the random planes we will classify how we will see now, okay. Yeah, here we can clearly observe that here this is the axis x, next to these are two axes, these are the some points, and these are the some other points, okay. When we create a 3 random planes here pi 1 pi 2 pi 3, and they have unit vectors w1 w2 w3. That means these are the points which are in this side. That means these points having plus value, that means same direction to the vector, we will make them as a like this. Here we can observe that every point w1 into x transpose greater than 0, we will that as a positive. That means w of x is greater than 0, we will classify that one is positive. For each plane we have create like this, okay. Because we have 3 planes we will create like this, hash function is like this. Here we will get for this region, because of these two are in same direction, this the same direction, we will get positive, and for this also it is the same direction, here also we will get plus, for this also it is the same direction, hence we will get positive, okay. Now coming to these points, for these points w1 is same direction, that means this one is positive. For w2 these are this side, that means opposite direction, here we will get negative, and here also these points are opposite direction, that means in this direction, okay. Here we will get -1, it was same thing that was represented, okay. When a query point came, only a query point xu came, it only search in this region only, this region, it won't go to this region, it won't go to any other region, because of we will have less number of time complexity, we will get low time complexity, yeah. And another thing we can follow these notes now, it's that is the Okay, another thing is by using the Euclidean distance, we'll saw the cosine similarity based method and randomized technique. Now it is the Euclidean distance based method. We'll we create a plane like this. We'll project the points to this plane. Okay, after projecting these points to the plane, we have the points like this that we can observe here. These are the points, and we will classify, we make the regions. Okay, now we will make the region. For each region, those the points which are in this region, we will send to the same values. That means it will give the within the same region, it gives the same key value by using the hash function. Here, instead of, because we have a problem, instead of using one plane, we will use the multiple planes, because to avoid the problem that we can observe here. By using the single plane, these two are classified into give the same hash function value. Okay, but they are far from this. They can observe these 2 points are far. Okay, to avoid this problem, we are using the another plane. By using another plane, it will project here, it will project here. Okay, they they are in same region in this plane, but they are in different region in the another plane. If the point is here now, then these two are in same region here also, and these two are in same region here also, in this plane also. Like that we will go. Okay, this is a good thing. Now we will see what are the problem. And one of the good thing in the KNN, we can also use the probability. That means instead of getting positive class or negative class, it is good to give the what is the probability. That means if k equal to 5, in the 5, 4 are positive points, 1 is negative point. Instead of giving it a positive class, we can classify directly 4 by 5 is the probability of the point correspond belongs to the class, positive class. That is the one thing. Okay, and now coming to the regression task. In the regression task, instead of, we will find the for k equal to 5, we will find the nearest 5 points, x1, x2, x3, x4. We will find these 5 points. We will consider mean of the 3 points are the value of 5. Okay, because in the regression we don't have class labels, we have only values. In the next video we will discuss how we can implement the KNN in Python. Thank you. Function F9